All right, folks, we're going to go ahead and get started with our afternoon tracks. You are in track 1, in case you were wondering, and this track focuses primarily around digital engineering and digital transformation. Our first talk is by Cesare Guariniello. He's a researcher from Purdue, and his research areas are space architecture, space robotics, system of systems methodology, dynamics and control, and model-based systems engineering. And Cesare is going to talk to us about digital engineering transformation at JPEO. So Cesare, over to you.
Thank you. I was joking. Welcome to all of you that decided not to go to Tom McDermott's talk. It's a little hard to it. It's a big competition. Just kidding. This is really interesting for me because out of I think right now I'm only on 4 SERC and ERIC projects, but out of 10 or 15 that I've been involved with in the past, I like this one because it's much more applied. I'm not a system engineer by trade or by training. I was, as you heard, dynamics control robotics. I was always very hands-on. So I think most people here, when they give their talk, they're way above my level. And they think in a way that is very different from the way I'm thinking, because it's always, there's a lot of things that we need to keep into account, all very important things on cybersecurity, on threats, on AI, on something. And then I always think that there's some poor students, because I started with SERC when I was a PhD student. Poor student has to figure out how to do the things that all these bosses say they're very important. Yeah, it's great, they're important, but how do we do that? And so in this project, we actually had to figure out how JPEO, that's the Joint Program Executive Office for Chemical, Bacteriological, Radiological, Nuclear Defense in Maryland, these people want to do digital transformation, want to do digital engineering, and they have no idea about any of that. We're literally starting from scratch. They don't know what's MBSC, they don't have any artifacts there, and they have a lot of people in their offices, a lot of program managers that have to figure out how to do this, and they have to talk to all the branches. So they have to also figure out what are their customers' needs. So we started with them a couple years ago. We began doing generic research that was portfolio oriented, how we select best portfolios, and there's the start of their digital engineering, digital transformation. And what we did, if you're familiar with SERC or you heard some of the talks today, you know that Purdue, we developed a tool bench, a set of tools for system of systems analysis that is called the Purdue Analytic Workbench, AWB. We started introducing them to our tools, to what we were using. And so in the beginning, what we were doing in this first study was identifying their needs, talking to all these program managers, and try to map these needs to digital engineering elements. We use a house of quality. So it's like, well, if you need to do this particular thing, this is your goal for you, program manager of that specific program, this is how digital engineering can help you. So we associated their needs with appropriate tools and methodology. Then we did a focus case study aligned with their goals of portfolio optimization. We used a couple of tools in our analytic workbench, and we developed this new tool called Decision Support Framework, where we could look at mission goals. We started introducing also mission engineering. Given the mission goals, what are the system capabilities that you need to put together? And if you have constraints and budget, cost, risk aversion, what is the best portfolio that you can put together? And finally, in this 2020-2021 study, we look at their actual portfolio, and this is unreadable on purpose because this is a JPEO portfolio. It's restricted technologies. We look at their specific portfolio and how they can use these tools. So this was a pilot study, an example of what they can do with digital engineering. Then they changed completely in 2022, new management, as usual happens, and they say, oh yeah, I'm not interested in portfolio anymore, which is funny because we were doing portfolio 2 years ago, and now that everybody's doing portfolio analysis, JPEO is not. And they decided, we want you to look at something else. We want you to look at what models we need when we want to do different things, when we want to achieve certain goals. So we started with, can you apply agent-based modeling techniques to something that we are not used to, for example, not CBRN threats, electronic warfare, if that impacts our sensor, how is our chemical, nuclear, radiological, bacteriological defense gets affected? So we started with this first study on ABM. And you will see next slide that there were some issues there on how to match our capabilities with JPEO and all the groups that they have there. But it was still instructive. The second part of this research effort, we went back to look at JPEO portfolio, but they actually asked us to look at application of additive manufacturing, AM. And in particular, there are two questions where, what can we do at the enterprise level? Where can we use AM? And the second, more important to them, is what should we do? What is convenient to us? And in particular, how we get ready for that? How do we get ready to decide where to use AM and where not to use? So what kind of models we need, and that's the connection with the digital transformation, what models we need to be able to evaluate when to use AM or not. So first part, it actually took a very small chunk of this research effort. This is an example of our paper model of how we model one of the possible interventions that JPEO has in their database. So how communication works, how hazard is reported to various parts of the branch when there's a threat, how it's neutralized at various levels. They have platoons, they have companies, they have decontamination units until the threat is neutralized. And then we added something like, for example, communication disruption. So we developed this model and ran simulation for them. The most important takeaway point here was that there was a big lack of digital engineering artifacts at JPEO to describe capabilities related to JPEO operations. So for example, we wanted to give this support to model system of system level artifacts like mission threats, scenarios, so to build this big ABM. But the problem is that JPEO had limited expertise in this field. And we have limited expertise in what JPEO is doing. So there was a long phase of JPEO training us on how exactly their operations work, so that we could have all these steps and all these actors to be put in our models. At the same time, we had to train them in what we needed, what kind of information and data we needed from them to be able to build our model. And so in the end, the important conclusion here was that most of the times when we're building agent-based modeling, they're tailored to answer very specific questions. So we found this barrier, and at some point, JPEO, that's the reason why we pivoted to a second part of this research, they basically say in-house development and in-house sustainment of these models, to us right now, is an investment that our managers do not want to do. Even if you prove that this is important, we think that it's better to use some other means, some already existing tool, for example, and we will, instead of learning the Purdue tool, even if it has better capabilities, we will learn about some other tool that's existing. We don't really want to invest to build our own and do our own specific research. Again, I don't know if this is a good strategy or a bad strategy, it's only what we found in this specific application. So the main lesson learned here was, well, this requires such a long time, we are not sure if it's a good investment up front. And it would be great if there's somebody that can demonstrate to them that most of this is a good investment up front. And I think actually we did some of this in our second phase, second part of this research. As I mentioned, they asked us to switch to study what kind of models or what kind of modeling capabilities JPEO needs to achieve so that they can evaluate and decide whether to use additive manufacturing in their products. This didn't come out of the blue. There are a couple directives, DoD instruction and also all document where the Army and DoD directed the use of additive manufacturing or advanced manufacturing. So basically, they've been mandated to at least look at AEM. So they decided to start of this. When I say AEM in this presentation, I mean additive manufacturing, which is basically 3D printing, something where you manufacture something by adding material instead than taking material off. The Army document, the Army directive actually mentions advanced manufacturing, which is a combination not only of 3D printing, but also of AI, robotics, advanced materials. We mostly did 3D printing with a little look at materials. And in particular, we look at two use cases. One, additive manufacturing as part of the organic industrial base for systems of part replacement. So imagine some soldier is out in a mission, is out in the field, rather than having to have a supply chain for repair for parts. If we have 3D printing capabilities on the field, we can do that quickly, we can do it in a more agile way. And of course, we have to look at, as you will see next slide, not only at this is quicker, there's a lot of other considerations that we need to keep in mind. The second use case is a little more complex because it using additive manufacturing as the original equipment manufacturer, so creating systems or part from scratch and then sustain that, which of course, as you can imagine, requires much more investment upfront. Since our group is specialized in system of systems, we began looking at what is additive manufacturing from a system of system perspective. There is not only materials, machines, as you can see at the lower level in the top left diagram, but we also have to think of who is designing it, who is manufacturing our materials, who is supplying. Do we need to do it in home because maybe there's some technology that cannot be used outside, or we reuse some already existing technology? And at even higher level, we have to think of additive manufacturing supply chain. And if we are thinking of the case study where we are using AEM to repair something, AEM might be used in combination with traditional manufacturing. So we also have to consider the TM supply chains. And as I already said, the two big questions that we had is, what can we do? Meaning, what technologies or what sensors or what products in use at JPEO can benefit from additive manufacturing. And this is more related to the lower levels from the graph, and it's more related to the materials, the machine, the specific technologies. And then we have what should we do? Again, JPEO is doing this digital transformation. Additive manufacturing can be useful. When is it useful to JPEO for that specific scenario? So here is where we also have to think of supply chain, suppliers, design design process, and so on. So we need to consider higher levels. So the first question, that's the easy one, what can we do? Actually, what we found out is right now, additive manufacturing is so advanced that you can do almost everything with AEM. What we did was literature review comparing state-of-the-art in AEM in industry with the JPEO portfolio, so the entire enterprise level. These are the sensors, these are the technologies, these are the components, and we found out various opportunities to study better. For example, components for face shield to make them more ergonomic and specific for each individual soldier, for example, that guarantees that they will be tighter, they will work better. Surveillance systems that are lightweight and can be carried in the field. Additive manufacturing for repair in the field. So the first thing that we found out is AEM allows almost anything. But then there are those couple points at the bottom. The first is there are additional considerations that we couldn't find in literature because they're very specific to JPEO. We are talking about, for example, going to places where there might have been a chemical contaminants. How do materials that we use for AEM react to those chemicals? Can we use the same material, or can we use AEM technology for some specific component everywhere? or only for certain specific scenarios. And another point that we found that will be touched again for the second question, what should we do, is some choices heavily depend on scenarios. If I have a mission where we go out in the field for 1 hour, the importance of having lightweight is much less than if we have to spend 3 days out in the field, maybe transferring personnel for hundreds of miles. Also, are repairs in the field feasible? Can we actually have 3D printing capabilities somewhere out in the field? So what came out here was again, not a clash, but it was some curious questions from JPEO, because they asked us, this is our list of technologies, just mark yes or no. Should we do AM or not? A binary answer. And our counter reply was, we cannot really give you a binary answer because it depends on so many aspects. What we can give you is a framework where you can look at all these aspects. We can tell you what are the aspects that you need to consider. And this at the bottom are a couple of them. Do we need lightweight or not, for example? Do we need 1,000 of this type of product, or we need only 10? So those are all questions that make so that even for the same product in their portfolio or the same technology, we cannot really give an immediate answer if you should do that or not. And another question, another answer, another point that comes out when we ask what should we do is what scenario are you using that, but also how much you're willing to invest upfront. So they know, of course, that there is a big investment upfront when you want to change completely. But here, because JPEO is talking to all the branches, there's other things that come to mind. Who is going to pay for this? If we do this investment upfront, is JPEO paying for this? Or is the Army or the Navy or the Air Force paying for this? Who wants to do the investment? Who owns the thing? So first of all, what we found is questions about the model. Simplest thing at the low level, you need CAD models, physical models for performance and requirements. But in the case of JPEO, we also want operational models, mission threads. We want to know how flexible we can be or quickly we can change operations if we introduce additive manufacturing. And this again is specific for the scenario. Supply chain models. So we go back to that. Who is going to pay for this? How we invest that? Will there be new requirements? JPEO needs to quickly and in an agile way respond to new threats. So how long does it take before we can do this? And then there are some other questions that are about the technology and the specific scenario. How does the distribution work? I already mentioned what is the expected production volume. Can we use AM capabilities that already exist, or are we starting from scratch? So because of these two questions, first, we just looked at volume, cost, lead time, which is how much you need to know ahead of time that there's a new threat so that you can produce your products to be sent in the field. So if there's something that requires weeks of lead time, it's unlikely that we're going to be able to produce that in the field. And finally, we look at part complexity, like how complex you can build a physical part with different technologies. And this table, we are comparing AM in general, just as 3D printing. And actually, this will be expanded in the future, that column of additive manufacturing, because there's different techniques and there's different materials we can use. And we are comparing this with various traditional manufacturing ways of building. And both the table and the chart show how the cost changes. And you can see 3D is in the left in the chart. So the cost per part is about a medium cost, but it works only when we got a low volume. So one very important item in additive manufacturing is it's not convenient if you have to produce thousands or tens of thousands of components, which are actually really good for JPEO, because most of the times when they have their portfolio of technologies and products, they don't have large production volumes. but we looked also at these other aspects. And these, as you can see, are related to the technology, so to the lower level. So this is a more immediate result, is use AM if you can do it, if it's easy to do in the field, but use AM when you got low production volume, and it will give you this cost. Now, the problem is these other considerations, which are the considerations at the high level. So what should we do? Data management. We need data protection, because now we're talking about technologies that might be controlled, classified, so we don't want to give them around. So most of the times we will probably have to produce at home, so JPO will have to have this upfront investment. Personal data is, if I'm doing the 3D printing for a mask that fits a soldier's face, is that health data, is that personal data, because I'm getting personal measurements. And so where we store them. Intellectual property, who owns the source of truth? If we do something, JPO does something with the Army, who owns that technology intellectual property? Is it the Army or is it JPO? The decisions whether to use AM or not might be different based on the product stage. So we know that in the beginning, introduction growth would be expensive. Another thing that we found out actually when we visited the Army Chemical Biological Center in Edgewood, Maryland, they told us different branches might be more or less open to use innovative technology. Some of the branches are more conservative, like, no, I don't want to do something that I don't know if it's 99.9% reliable. So I'm not ready to invest in this. And so CBC confirmed most of these points that we found with literature review and expertise considerations and with our models. They also showed that they have expertise in flow of data, in ownership and maintenance, and in materials. So actually one of our recommendations for JPO was, if there are other entities like the Army CBC that already have some of these capabilities, use them. Don't reinvent the wheels. Of course, you will not be able to use these capabilities from the Army CBC with other branches, but meanwhile, use that with the Army. And so in the end of all these studies and all these talks, we listed a few recommendations. The simplest, more direct is additive manufacturing is very useful, especially for small production volume. Second is studies are necessary, not only for specific items, but for specific scenarios and missions. We couldn't tell JPO, yes, this item 3.4 in your portfolio, do AM there. So it's hard to give a direct answer. You have to reason at the enterprise level, so thinking also of the cost of the supply chain. But you want to begin with low production components for various reasons. First, because we've seen that AM is better at low production volume. And second, because if you got it wrong, at least you didn't spend money to build 10,000 pieces or 100,000 pieces. Understand why or which AM technology insertion is most effective. So look not only at cost, but also effectiveness, viability, ease of operation in the field. So in the end, we suggested that they need more detailed study and they need to start doing these studies by individual scenarios and not just by looking at their whole portfolio and wanting the binary answer. And finally, use existing expertise. For example, CBC is already running cost-benefit analysis for specific scenarios. Begin using those. And I think this was the last point. So thank you.
Questions? Oh, sorry. Any questions in the room for Cesare? While you all are thinking and our virtual participants are putting their thoughts and questions in the chat, one thing that occurred to me while you were talking, Cesare, is you talked about the struggle with sort of understanding the value proposition of digital engineering activities. And, you know, Ms. Baldwin had the slide in her earlier talk that talked about where you are in the life cycle and you know, kind of where the value proposition is. So just kind of wondering if any of your agile manufacturing work has helped you make that case from that perspective. So as you said, the answer is it depends. It's our favorite answer as systems engineers, but has it helped you cross that barrier?
Actually, here there's an answer that is different from it depends. I saw exactly what Ms. Baldwin said when she said, oh, we're using MBSC at the very beginning. That makes it much easier. So our problem with JPO is that a lot of their processes are already existing. So when we're talking to all these program managers, like, well, I never used MBSC or never used digital engineering, and I've been doing this way for 20 years. Now it's really hard for me to start because I already have final products. So actually, since JPO evolves their technological portfolio over time, a good idea would be to tell them, hey, there's something that you never produced before, you never studied before, start using DE on that product, because at least you will start early in the design stage or even pre-design and pre-decision.
I just want to enhance what you just said. Our organization helps in the airport program offices to apply digital engineering rigor to the cyber assessment tools and modeling the cyber aspects of a weapon system. And you can spend all the money you want to model it for them. You can build the whole model and hand it over to the program office, but the processes don't change from a paper-based, configuration control boards, et cetera, like that. The people who are doing those configuration control boards still expect you to print things out and hand it to them in a PowerPoint presentation. So you're not really assessing the model. There's a few areas of expertise or excellence where they're starting to do that. I know in our authorizing official for aircraft, they're starting to actually take models as the input to doing the cyber assessment of a weapon system. But that's only happening in a small amount where the model has actually gotten good enough where you can actually trust the risk assessment that's coming out of it. There was something else I was going to mention about your additive manufacturing. Did you look at the scenario where they use it really for prototyping? So, in the field, the users have an idea of how they can improve a particular piece of equipment. We did this in the labs where we would 3D print new parts for our labs in our simulators, and we would perfect the part in the CAD model before going off and shipping it to have a bunch of them created. So I'm just wondering if that was one of the scenarios you looked at for JPO as well.
We didn't CBC is doing that. So actually, when we visited there, they show that, and of course, we all agreed together with JPO sponsor that were there, that it's a good idea. Right now, JPO is doing absolutely nothing with AM at all. So that I'm pretty sure that to them, the idea of like prototyping in the field is not great, but that's why we suggested them, okay, if CBC is doing the prototyping in lab, why not to use that? Like, why don't use the smart thing that other people are doing? So yeah, we are not modeling that, but I think they should.
Hi, TJ McKelvey with the Navy. Which of the branches was the least innovative and why was it the Navy? Serious question. Did you have any, so we deal with additive manufacturing. One of the problems we have is assurances that the file that we have is the right file and is producing the right part. And you talked about data protection, kind of protecting, people seeing the file. Is there any, any of the data protection actually ensuring the authenticity of the file that you're printing?
Yeah, that's a good question, because before that, the first question is who owns that? And once we answered that, what we did in the first year when we weren't thinking yet of additive manufacturing, what we propose is for files that we are sure that are internal to JPO, the best ways to use existing methods in the field first of all, for security, for access, like grant different access and grant access only to people that really need to see that file. And then the assurance is something that people are not really thinking of, and it's really hard, especially to people that are used to use only paper models. It's like, who tells me that this model is the right one? So what CBC is doing, for example, they have this reserved access, but it's a database that they create, they maintain, and so the assurance is kind of in-house just from the fact that they know they built it. JPO for now, I think what they're oriented to is that they will try as much as possible to keep that outside the house. So if it's JPO technology that they're proposing, then they will keep in-house. But if they're using CBC products from the Army, it will just be the Army property. And so JPO doesn't really care about the model because they will not be building, they will just be acquiring for the armed force. But that's a very good point that they need to consider. Also, I can't remember who was the least. I don't know if it was the Navy, but I can't remember who was the most aggressive. Do you remember Waterloo? They told that I can't remember, probably the Marine. Said somebody was really, yeah, we don't care, just let's not test on the field.
Any further questions? All right, thank you.
Thank you.